Some more kitchen table astronomy with Hampshire College astronomer Dr. Salman Hameed, Mr. Universe. There are things that we don't know about our future. It's wide open. But one thing that we do know, thanks to science and astronomy, is that eventually the sun is going to eat our planet. And, at least recently observed, another sun has eaten another planet.
Right. Well, I thought you were going to say, the certainty of death and taxes or
that,
something like that.
We know that too.
Okay.
Yeah.
So, although I should say our planet is most likely going to be eaten by the sun. There is still a little bit of uncertainty. Not that it matters, because life would no longer have been possible on our planet for a long time before that. But still, that's an interesting question. Well, Mercury and Venus certainly are going to be eaten by the sun about 5 billion years from now, when it expands, and it expands into red giant phase.
Because right now it's a red dwarf, right?
No, it's a yellow star.
Yellow star.
Yeah. So, but it's going. Then, what happens is that once you run out of fuel, right now, right at the center, you have hydrogen turning into helium, and that is what is providing the energy source. Mm-hmm. And but eventually, you're going to run out of hydrogen to fuse into helium at the core, and so basically, you have less energy in the center, and the core will shrink, because at that time, you won't be able to fuse helium into anything else. But if it shrinks, it gets hot. And if it gets hot, then you eventually get to about 100 million degrees at the center, and you can start fusing helium into carbon. And so you have sort of like new energy source in the middle, which is much hotter, and that leads to sort of like a bloating or the expansion of the outer atmosphere. And as it expands, it gets sort of farther away from the central heat source. It appears a little bit redder, which is a little bit cooler than our surface temperature right now. So when you look at the sun right now, it's around 5,000 degrees, roughly around 5,000 Kelvin. And then it's going to be around 3,000, 3,500 degrees Kelvin.
Bigger and bigger. It'll take over Mercury and Venus and maybe Earth.
Maybe Earth and Mars as well. And as it happens, the outer planets, Jupiter and Saturn, which are very cold right now, they may be actually in a cool place, maybe even in a habitable zone.
Wow.
And we talk about, for example, the moons of Jupiter and Saturn, which have oceans. We've recently talked about that as well. So maybe, the conditions may get better. For example, Saturn's moon Titan, there are some science fiction stories about that eventually in 5 billion years, that's a nicer place. Except, remember, that phase is not going to last very long, and the sun is still going to be quite unstable, and eventually it's going to turn into the core that will be left, which is the size of the Earth, and it is called a white dwarf. Mm-hmm. And that's sort of like a very high density. It's a density of an atom that will be there. Now, and the outer envelope of the gases will be left out. First, it's going to be this beautiful object called, what astronomers call a planetary nebula, where you have this core in the middle, surrounded by these beautiful glowing gases. And then we have lots of examples of those. So we know stars like our sun go through that phase, and eventually those gases are going to dissipate, and you are just going to be left with this core, which is the size of the Earth. Basically, you take the sun and put it down sort of like, size of the Earth, condense it into it, very high density, and that's what's called a white dwarf. And it will just be like that. Cool. Initially, it's going to be very hot because the core is hot, and then it's just going to cool down forever. And so that's, sorry to sort of like, be a little down today, but but that's what's going to be. And so as you started this conversation about, well, but it's going to eat up Mercury and Venus as it expands, do we have any examples of that? And just recently, a new paper have come out in the journal Nature, in which they have actually seen meaning to say they can infer from what has happened that a star like our sun has eaten a planet.
And did it use the same process? It ran out of fuel. It became Wookie. That's Wookie the dog under the kitchen table at Kitchen Table Astronomy. Wookie does not like the idea that this star has run out of fuel. But is that what happened? It was no longer able to convert hydrogen into helium, runs out of gas, literally, and then starts to expand?
That's exactly right. So this particular star is about 10 billion years old. It's It's a star like our sun, so it has gone through that phase. And there were some astronomers who were looking for something else, which I just find it really cool. They were actually looking for colliding stars or merging stars, which are called red nova. Again, that's a separate conversation, but that's what they were looking for. And in their data, they found this anomaly, this a little sort of like brightening of a star, which was a little unexpected. Usually with this colliding stars or merging stars, you find these to be much brighter. But here was a case where there was a little bit of brightness, and they were like, well, what is that going on over there? And then they went back and looked at the older data. They took some new observations, and what they found was that here is a case where a planet, probably the size of Jupiter or a little bit bigger than that, so a gaseous giant, and that had been eaten up, swallowed by this star whose envelope had expanded. So this was an expanded red giant, and this planet was close enough. And what is really cool is that they can actually look at the data and for the previous sort of few months as well. And what they found was that the planet was already interacting with the envelope of the star. And so there was this interaction going on, and eventually this brightening was when this planet exactly got actually absorbed by that star.
It's like when you're toasting a marshmallow. Your marshmallow interacts with the fire if you get a golden brown, but if it gets really hot, huge conflagration, your marshmallow's on fire now.
That's right. So and remember, this is one of those cases where you know that marshmallows get sort of burned. But can you find that instant? So the reason why we knew about it was because astronomers had seen some other red giant stars, where if you look at the envelope, in the gaseous, if you look at the composition of the gaseous envelope, you can actually see materials that are usually present in planets. So we knew, we know this happens. And then astronomers also knew that many of those planets that have been discovered, with all these exoplanets, more than 5,000 have been discovered, some of them are very close, orbiting very close to their stars. So we know, okay, that means that they are going to get swallowed, but this is the first instance where they actually found it in the act of being swallowed. And that's actually, I think, really cool, because what astronomers call this is sort of like the missing link, meaning to say, okay, they knew that it had happened. They had seen sort of planets very close to their star. And this is the case where they caught one right at the time happening.
This is amazing, too, because, and you mentioned this, that we know about 5,000 exoplanets outside of our solar system. We theorized for a long time that these planets existed. We know there are billions and maybe trillions of galaxies, but we couldn't really prove it until when?
Well, that was in the 1990s.
So very recently, until we could say, yes, now we have actual evidence. We knew we had a theory, but now we have evidence.
And this is one of those cases that up until the 1990s, we only had one example of a solar system, right? So we know that, okay, well, this is how planets form. And so our theories were also based upon the idea that the way we had theorized how Mercury, Venus, Earth, Mars, and so on and so forth, they form, all of our theories were based upon that. But then we started to find very different kinds of solar systems. And you go like, whoa, wait a minute. So there are other ways that star systems also find. And so once you get to these numbers, like 5,000 or so, you can really start doing science with those, meaning to say you can actually start creating pictures as well of how these different types of systems may have formed and how they evolve. And this particular case, what's sort of relevant to us, because, Monty, it's all about us.
Yes.
That is that it's a system like ours, and so in this case it gives us a glimpse into our own future, even though we will be long dead. And by we, I just don't mean me and you, Monty, but we, I mean everybody here, because life would not be possible even a few billion years from now, because of changes in the sun, and it's getting hotter, and so on and so forth. So it's not about that. But you can imagine if there are advanced civilizations out there. This happens in every star system, like the Earth or the Sun-like system. This is going to happen over there. And we know that every star system has planets. And we know some planets are close to the star. So this is a story in some sense that is happening countless times in the universe. And maybe there are some civilizations out there, or sort of like, advanced beings, and they also calculate, for example, that the sun is, their star is going to expand, and sheesh, we better do something. And then they have their political differences and they say, oh, it's not real. Climate change doesn't happen, a sun change doesn't happen. So we don't hear from them anymore.
Yeah.